Alright, welcome to John Stewart's Calculus Early Transcendentals 9th edition. This is problem number 39 from section 3.3 by request from Carolina. So we'll jump right into this one. Basically it's asking for what values of x does the graph f have a horizontal tangent. So the first thing to figure out is what the question is asking for. And it's asking for horizontal tangent line locations. So when will a tangent line be horizontal? Well, the short answer is when the rate of change, also known as the slope or derivative, is equal to 0. Let's look at a few tangent lines real quick to see why. And remember that slope is equal to rate of change, which is also the same as rise over run. So with this first tangent line that we're looking at, for every 1 unit in the x direction, it's going up by 2 in the y. So in this case, we have a rise of 2 and a run of 2, and our slope is 2. With this next one, it's 1. For every 1 that x goes across, it rises by 1, so it's 1 over 1, and the slope is 1. For this next one, for every time x goes 2 units, y goes up by 1, so it's 1/2 or 0.5. And finally, for the last one at the bottom, there's 10 units along the x direction, and for every 10 units on the x direction, it only rises 1, and you get 1/10, which is basically 0.1 as your slope. What you'll notice though is that with each one, this tangent line is getting closer and closer to horizontal, and as it does, this number is getting smaller and smaller and smaller. It went from 2 to 1 to 0.5 to 0.1. And if we look at an extreme example where there's, say, 100 units in the x direction and just 1 unit in the y direction, it's now down to 0.01, and it's getting suspiciously close to 0. So in fact, if there's no rise at all, if you take 0 and you divide it by any number of x units, it's always going to be 0. So a horizontal tangent line is basically going to have a slope of 0. So let's start by taking the derivative. Our basic sine derivative rule is just that the derivative of sine of x is equal to cos of x. And our basic derivative rule for x is just that it equals 1. So with our function, we have x plus 2 sine x. You can basically think of this as taking the derivative of the first part and then the derivative of the second part separate, and I took that 2 out because it's a constant. Of course, the derivative of x is just 1, and the derivative of sine x is just cos x, so you just end up with 1 plus 2 cos x. So now step 3 is to figure out where is this derivative going to be 0. So I'm just going to replace that f prime of x with a 0 and put it equal to the equation. First step is I'm going to move that 1 across, so the positive 1 becomes negative 1 as I move across the equal sign, and then I'm going to divide by 2, which is going to give you negative 1/2 equals cos x, or if you flip it around, when cos x equals negative 1/2 is when the derivative will be 0. So now the next question though is to figure out when is cos x going to be equal to negative 1/2. So the easiest approach, what I'll call approach E, is you just grab your unit circle. So this is just a random unit circle I got off the internet that I stole. And here, you'll see that the first digit there is the cosine value, right? So if we look for negative 1/2, where do we see negative 1/2 on this unit circle? Well, the first instance occurs at 120 degrees. You can see that the cos value is negative 1/2. Whereas the second, well, it looks like at 240, it's also negative 1/2. So basically what that means is that cos of 120, which is the same as 2 over 3 pi if you prefer to use radians, is equal to negative 1/2. And we can also say that cos of 240, or 4 over 3 pi, is equal to negative 1/2. So it's a little bit more complicated though, because if you went all the way around the circle a second time, it would also be 1/2. Or if you went a third time, or a fourth time, or a fifth time, or a sixth time, every time you went around and you touched that spot of some multiple of 120 or some multiple of 360 degrees plus 120, it's going to get you back to the exact same place. The same applies if you go in reverse around the circle. So basically it ends up being 120 plus or minus 360 degrees however many times you want will also give you negative 1/2. So the full answer is basically 120 or 240 plus n times 360, or if you're in radians, it's going to be 2 over 3 pi or 4 over 3 pi plus or minus n times 2 pi, which basically just signifies that if you go 120 units from the origin, you're going to get negative 1/2, and if you went a full circle around again, you'd still get 1/2. So that is the solution to the problem. So there's basically a couple steps. The first one is you have to figure what it's asking for, which is a horizontal tangent line, then think, what does that mean? Well, that means that the rise over run is going to be 0, or the slope is going to be 0, or the derivative is going to be 0. It all means the same thing. And then you got to take the derivative, put it equal to 0, solve for your x basically, and then basically figure out for which values of x is the inequality true. And yeah, if you have any more questions or there's a specific problem you'd like to have solved, just let me know, and I'll try to solve it for you. Thank you. Goodbye. Oops, I guess I should have said that last bit on the slide. So yeah, if you're looking for a solution to a specific problem, just put it in the comments below, or feel free to email me a picture of your question. My email address is in the description, and please consider liking this video so more people find it. Thank you. Goodbye.